Hi, my name is Bruno Gobato. I'm an orthopedic surgeon from Brazil. First of all, sorry about the sound. I'm recording just next to my 3D printer, so you may have some sound problems. But this is a homemade video showing my Sunday duty for today, and I would like to share with all you guys. I'm a shoulder surgeon. I'm not very into hand deformities, but a patient of mine, knowing that I work with 3D, asked me if I could help him, and so I'm going to help. I'm going to try measuring some deformities of his hand, and I'm going to show you guys in real time how I do this. For a start, this patient had a fifth metacarpal bone fracture. I think it's one or 2 years now, and he has a rotational deformity of the fifth finger. Oh, sorry, and he complains about mild pain and some strength deficit. Okay, I'm going to open here my 3D software. Let's put this webcam a little smaller, and here we can see, so we had a CT scan from both his hands. Okay, the problem is in the right hand. So we have here, if you can see, we have here in white, I'm just selecting the right hand that has the problem, and in blue we have the left hand. So the first step is now to mirror the left good hand into the right hand. So we just go here and mirroring. Let's just do this. Okay, I have mirrored, as you can see here, and now I'm going to overlap these two bones. So let's make sure everything is in correct position. I have already done here some plans for measuring. Okay, and okay, we have here this is the best overlapping I could done. Okay, so I tried my best to overlap in the proximal part of the fifth metacarpal. Okay, and here I'm going to show some measurements. We have here a blue and a red lines, and I choose the base of the metacarpal. So I choose these both lines to be overlapping one each other in each model. So I'm sure that both models are in the correct height. Okay. And then I have measured here the length of the normal and the length of the affected metacarpal. So here in red we have the length of the normal metacarpal, which is in blue. And here in green we have the length of our desired metacarpal, the right metacarpal, which is in green. So here we can measure the shortening. Just click here, analyze distance, and we have a 3.5 millimeter shortening for this kind of measurement. But we suspect that this patient had a rotational deformity as well, and this is not that easy to evaluate. Here we can see our overlapping. It's not actually perfect, but we can see here that the proximal and the both proximal and proximal phalange of the fifth metacarpal are very not in the same position. Okay, although the other fingers are in very good position. So we can check here that this patient has a shortening as expected, but we suspect that the rotational deformity is worse. So we are going to select only the metacarpal bone, okay? And let's copy to another position. So here we have the metacarpal bone. Let's do this, and I'm going to show you first here. So we have copied the metacarpal bone. We have here in yellow the normal metacarpal, and in red the affected metacarpal of this patient, okay? In yellow is the left mirrored metacarpal. So we have tried our best in order to align the base of the metacarpal principally in height, but in rotation, okay? This was not a very easy task, okay? But we think we could done a good job. As you can see here, I'm going to move a little bit in order to understand that the rotation is almost aligned, both metacarpal. Okay, let's go back. And for the purpose of this video, we have already done some measurements. So here, what we did. We have here the affected metacarpal, okay, and the normal metacarpal, okay. And here in blue, we choose a osteotomy. We have done a osteotomy on the affected metacarpal and try to rotate it just like that in order to make sure it's aligned with the normal metacarpal in the rotation position, okay? And this is what we have achieved. We think these both files right here, yellow and blue, are very well now aligned in rotational deformity, and we can use this line here as a reference to check out our rotational deformity. So let's analyze angle 1 point over here, and then the other point perpendicular, and we have a 153. So 180 plus 150, we have a 27 degree of deformity. So we have a 27 rotational deformity to correct this patient. So this is how we think it should be. Let's move down back. And for correcting for this patient, we should have this correcting the shortening, but also the rotational of this metacarpal bone in 25 degrees. Now we are going to create some measurement devices, 3D printed measurement devices, to help the surgeon perform the surgery. I'm not going to perform it, to help the surgeon perform the surgery and have the correct ways to check for the length of the metacarpal bone, but principally for the rotational. We are going to use the pre-drilled holes from the plate in order to help the surgeon check for the rotational and even for the distraction of this patient. So we are going to create a ruler, actually like a ruler, that is going to use the pre-drilled holes from the plate in order to check the correct position of length and rotation. So Thank you for watching. This is a small video, almost like a demonstration, showing how we can do this. And this is not easy, as you can see. It's not a perfect method, but I really think it's way better and way safer than just looking into the surgery. Okay, thank you. Bye-bye.